Okay, well, happy Friday, everybody. You made it to the end of week 7, and so we just have a few weeks remaining. I guess about 2.5 weeks. Next week there's a holiday on Monday, President's Day. So we'll pick up on Wednesday. Yeah, you got weeks 8, 9, and 10. That will be it. Regarding the final exam has been scheduled by the registrar's office. It's going to be Monday, March 14th, but it takes place at night, like 6:30 to 9:30 p.m. We'll do a remote synchronous exam. So you don't necessarily have to be, on campus, but you do have to, I'll set up a Zoom link. You'll log in, and we'll have some, minimal level of proctoring there, and yeah, it'll be you'll take it on your computer. So I'll provide more details about that in the coming weeks. Okay, but let's go ahead and take a look at our lecture topic for today. We've been talking about object-oriented programming in Python, and so today's topic, we will kind of continue expanding on that, and we will take a look at classes and inheritance. Okay, and so my content is taken directly from ThinkPython, so I can't claim any credit to any of this stuff. But let's go ahead. So when we create classes, what we can do is we can create related classes that inherit from kind of the parent class. We're gonna create a new class that's basically a modified version of an existing class. Okay, so it's kind of like if you think about animals, you could create a class animal, and within that you can create a class vertebrate, and within that you can create, like, say, mammals. And so mammals would be, a type of vertebrae. And then from within mammals, you can have, like, cats and dogs and cows and things like that. And they would all be kind of modified versions of mammals. Okay? If we were imagining some kind of system like that. So in what we'll do is we'll use we'll use playing cards as our objects. We'll also have classes to show a full deck of cards, and also like poker hands. So if you're not familiar with poker, I'll try to briefly explain, but basically if you have 5 cards, so there's different versions of poker. You can end up, basically, you pick the 5 cards that score the most points, or or have the highest, points isn't really the right word, but have the highest value. And in a lot of games you're kind of given a total of 7 cards or something like that. So anyway, let's talk about this. In a standard deck of cards, there are 52 cards in a deck, and we have 4 suits: spades, hearts, diamonds, and clubs. And here I'm using, in the game Bridge, this is the order of suits, being spades being the most valuable suit, and clubs being the least valuable. Spades and clubs are colored black. Hearts and diamonds are colored red. And spades and hearts are considered the major suits. They're worth more. Diamonds and clubs are the minor suits, considered to be worth less. Within each suit, there are 13 values: ace, 2, 3, 4, up through 10, and then jack, queen, and king. And what we'll do is we'll define a new object to represent a playing card, and the attributes of this playing card will be its rank and its suit. So how should we store the attribute? This is not necessarily obvious. One is we could use strings, but if you use strings, it's not going to be easy to compare cards to see which one has a higher rank or suit. Because if you do something like, sure, 9 is greater than 8, and 8 is greater than 5, but, is the king greater than the queen? As far as the cards go, the king is worth more than the queen, but if you use strings, it'll sort by alphabetical order, and we would say king comes before queen in the alphabet, and therefore it's going to have a lower rank. So instead, we're going to choose to encode the ranks and the suits numerically. And so we'll say, Jack will be numerically worth 11, queens will be numerically worth 12, kings will numerically be worth 13. And then as far as the suits go, we'll give spades a value of 3, hearts 2, diamonds 1, and clubs 0. Okay? And again, these aren't actual point values or anything, but it's just a way for us to sort these cards and rank them in order. And so this is how we can define a class card. Okay, so class capital C card, and we will just say, when you create a new card, you'll need 2 values. We'll have the suit, which will be 0 by default, and rank will be 2 by default, which will be kind of the lowest rank, and we'll just say self.suit and self.rank. These will just be numeric values. So, for example, the queen of diamonds would be stored numerically as card 1, 12, where 1 corresponds to diamonds and 12 corresponds to queen. Okay, now here I'm kind of manually naming it queen of diamonds, but internally, just numerically, we would store this as 1, 12. Okay, now in order for it to be useful to humans, we'd probably want to have a string representation that will be helpful for us. So to kind of go back from the integer codes, say 1, 12, suit is 1 and rank is 12, we can try to make the string representation, which is how it will appear when we print it. Okay, so what we're going to do is I'm creating a list of string values. Okay, so we've got suit names, and then the suits, they go from 0 through 3. So if it's 0, it'll be clubs, 1 is diamonds, 2 is hearts, 3 is spades. And then as far as the rank goes, we go 1 through 13. Okay, and so here's a list that is of length 14, and we have a 0 for. You can't have a rank 0, so we'll just say none here. But if rank comes in as 1, that corresponds to ace. If it comes in as 2, it's a 2. If it comes in as 11, it'll be jack. 12 is queen, and 13 is king. And so we create a function, double under string. Okay, and this is how the card will get printed when we call print. Okay. And so here I've got the curly braces, and I'm using dot format. So the curly braces, :s means format as a string. And so it's going to be string of string. The value that goes into the first part will be the rank. So we're going to take self.rank, and we're going to select from class definition card.rank names. We will subset to the self rank, and then as far as card suit names, we will find self.suit, the value there to pull all of this. Okay, does this make sense as far as the string representation? How we're going to print this out? Okay, so these things, suit names and rank names, these are defined inside the class, but they're not part of any method. Okay, these are called class attributes because they're associated with the class card. And so if we want to access these things, we access them using card.rank_names or card.suit names. Okay, it's not preceded by self, and that distinguishes them from variables like suit and rank, which are instance attributes. These are values associated with a particular instance of the class object. So for a particular card, the suit and the rank could differentiate themselves, and so those are all have self.rank, self.suit, and we list this off this way. Okay, so we create card 1. It's going to be suit 2 and rank 11, and when we print this out, our class definition says this is the Jack of Hearts. If we do 1, 1, this will be the Ace of Diamonds, and so on and so forth. 3, 6, this will be the 6 of Spades. So Spades is suit 3. Okay, and so now we have a way to we can store all of our cards, and when we print them out, they are readable by humans. All right, what if we wanted to compare 2 cards and say, is one card worth more than the other? Yeah, question. Yeah, so if you were to get 0, okay, well that, I guess when we, inside the initialization function, we could have a check to make sure that that the suit and the rank being passed to it are numbers and things like that. So if we pass rank equals 0, what it will do is it'll say rank names as none, and then so when you convert that to a string, it'll just be empty. Yeah, and so it won't be a valid card. That's not a valid card. You can't have the none of spades or something like that. But so there's no, right now as we have the class definition defined, there's no check to make sure that the inputs coming in are valid, and that's something we can do to kind of make it stronger, is to make sure the check for the validity of inputs. But right now that's not a thing. Before I forget, let me go ahead and give you your first view quiz answer for today, which is the letter A. A as in apple. A as in apple is your first view quiz answer. All right, so we can, we've seen comparison operators used to compare different types, built-in types. So we can use comparison operators to compare, say, just numeric values, strings. We also saw it used to compare tuples and other values, right? What we can do is there is a special method, LT, which stands for less than, and then there's another method, another double under method called EQ for test for equality. And these will get invoked anytime you use less than or greater than, or the double equals to test for equality. And here we'll say, what if you want to compare one card with another card? Okay, what if you want to compare one card with another card? How should you do this? So, when you compare cards, there's a few ways to do it. What we will choose is we will choose ranks, suits to be more important than ranks. Okay, so we'll say suits are more important than ranks. So all the spades, so the most valuable will be what, like the ace of spades, and then we'll say the weakest spade, the 2 of spades, is still worth more than, say, the ace of diamonds, and so on and so forth. That's an arbitrary decision. Somebody else might say all the aces are worth more than all the kings, which are worth more than all the queens. That's another choice. There's no set, depending on the game, which one is worth more or less is, depends on the game. Okay? So what we can do is we can use a tuple comparison. right? So we know how tuples work. It compares the first element, and if one is greater than the other, then it'll say the one that's greater wins. But if the first element is tied, then it goes to the second element, and it compares those. And if those are tied, then it goes to the third element. And basically, it keeps comparing element by element until there is a difference between the tie, and whichever one's greater will be chosen as greater. Now, if the first element, so if you have object A and object B, if the first element of object A is greater than the first element of object B, it doesn't matter what the second element is, right? It just compares the first element and compares them likewise. So here I'm adding two double under methods, okay? And what we're going to do is we're going to create a tuple and a tuple, okay? So when you do the less than operator, it's always expecting one on the left-hand side and one on the other on the right-hand side. And we're going to ask, is the left-hand side less than the other card? So we create a tuple, self.suit, comma, self.rank. And again, I could have swapped these and we could have said all the ranks, all the kings are worth more than all the queens, which are worth more than all the jacks. But the way I have this tuple created, I have the suit first. So we're saying all of the spades are worth more than all of the hearts, which are worth more than all of the diamonds, which are worth more than all of the clubs. That was an arbitrary choice, but we could easily just swap these as well. So our first tuple is suit, self, suit, and self rank. The other tuple is other suit, other rank. And now that I've created these tuples, I can just compare the tuples. Is tuple 1 less than tuple 2? And whatever result that is, we'll return it. So this will either come back as true or false. True if tuple 1 is less than tuple 2. To test for equality, I just do equals equals. Okay, so I create two tuples as well, tuple 1 and tuple 2 using the self and the other. And then we're going to just return whether those two tuples are equal or not. Okay, does that make sense? And so, yes.
So how does it rank by the tuple? How does it rank which one? Is it checking if it's equal first, and then if it's?
Well, so it's just doing an inequality here. So let me see. So let's say you have one tuple, which is we'll do 2, 10. So this will be tuple 1. And then tuple 2, I don't know, will be 2, 11. Okay? So when you do tuple 1 less than tuple 2, it's going to compare the twos, those are equal. Then it says 10 is less than 11, so this will come back as true. If I create a third tuple, and the third tuple is 0, 13, okay? And if I say it's tuple 1 less than tuple 3, okay, it compares the 2 versus the 0. So it doesn't matter what's in the second spot in the tuple. It says the 2 is greater than 0, so this will come back as false. So anytime you do tuple comparisons, it's going to kind of look at just these. So here we just have some numbers here, and so those are compared quite easily. Okay, and you can kind of think of it as almost like if you think of a word as a string as a tuple. How do you alphabetize words, right? You first look at the first letter, and if it's tied, then you go to the next letter, and if it's tied, you go to the next letter. And so any word that starts with A, it doesn't matter what the second letter is. Any word that starts with A is going to come before any word that starts with B. Okay, so AZ comes before BA, right? So that's just how we compare tuples. Okay, so here, let me just show you the comparison operators in action. We've got card 1 is going to be the queen of diamonds. card 2 is the Jack of Hearts, and we said all spades are worth more than all hearts are worth more than all diamonds are worth more than all clubs. Okay, that was just a design choice for how we're going to do this. So we're going to do, is card 1 less than card 2? Is the Queen of Diamonds ranked lower than the Jack of Hearts? That's going to come back true. Okay. Here's another card. We're going to call this the Queen of Hearts. And we'll say, is the Queen of Hearts worth less than the Jack of Hearts, which is card 2? And that comes back as false. Okay. So we have a way to compare one card with another. Okay, card 4 is the Queen of Diamonds, which is the equivalent to the card 1. So card 1 is card 1, 2, Queen of Diamonds. I've created card 4, which is the Queen of Diamonds, and I could say, is card 1 equal to card 4? Do they have the same thing? That is true. Over here, we have the Queen of Hearts. Is the Queen of Diamonds equal to the Queen of Hearts? That's false. Yeah.
And this is all that we did the dunder.
Yeah, because this is all part. We are able to do this because we did the double under, dunder less than, and the dunder equal. Okay. If you don't implement the less than and the equal thing, the double under LT, double under EQ, you cannot do these kind of comparisons between class objects. Okay. So this works, right? Just like if I were to try to do a plus, this would not work, right? If I say do card 1 plus card 2, the computer won't know what to do because I haven't implemented a dunder add method. Okay, so on the last lecture, Wednesday's lecture, we had time objects, and we implemented dunder add, the double under add, and we were able to add time objects together, and we did it in a way that makes sense. As far as cards go, what does it mean to add cards? You know, it doesn't really have a logical operation, so there's no I don't think it would make sense to make a dunder add, but let's say we did find a way to add cards together in a reasonable way, then we could implement it, and then we could use the plus operator. And then once you have the dunder add method, then you can start using functions like sum, and it will add a bunch of things together and stuff like that. But yeah, what does it mean to try to add the 7 of spades and the 9 of clubs? I don't think it makes sense to add them, right? Okay. All right, let's talk about building a deck. So now that we have cards, what we can do is we can define a deck, okay? So a deck is made up of cards. So we will think of the deck as one of the attributes will be a list of card objects, okay? A list of card objects inside the deck, and that's how we're going to define the deck. So we're going to create a class definition for deck. The init method creates the attribute cards, which will be a list, and it's going to generate a set of 52 cards. And then string is you're going to take the list of all of those cards and join them all together. So this is how we're going to define the deck. When we create a new deck, we're going to create an empty list, self.cards, and then we're going to just go through 2 loops. We're going to say for suit in range 4, so starting with suit 0 going up to suit 3. So we'll repeat that, and then we'll do for rank. Okay, so we're going to go through all 4 suits, and within each suit we'll go through all 13 ranks. Okay, and then we're going to just say create a card using the suit and the rank and append this to this list, right? So we take self.cards, which is a list, and we're going to append the card that we just defined here. And so we'll go through all 4 suits, all 13 ranks within each suit, okay? And that will create a list of cards. And then when we say print out the deck, okay, when we say, what's the string representation of the deck? Okay, I'm going to take, we're going to go through all of the cards, Okay, so for every card in self.cards, we're going to turn them into strings. Okay, so as it is, this list of cards, they are card objects, and we want to turn those card objects into something that we can read, like the string Jack of Clubs or the string Six of Hearts. Okay, so we're going to take all of those cards within the card object. We're going to ask for the string representation of the card, and we're going to append that into a list called results. And then once we've created that list of results, we're going to join them all together using new line characters. So we'll do /n join, and that will join all the results. Okay. So here I'm going to just create a new deck, and then when I print out the deck, this is what it will look like. Okay. So it says Ace of Clubs, 2 of Clubs, 3 of Clubs. We've got the string representation of all of these things. Okay. So this is what appears when we print it, but keep in mind, inside this actual list, the list itself, self.cards, is a list of card objects. It's a list of card objects. All right, so what can we do now? What we can do is we can take a few, write a few methods, okay? So one is we could deal out cards. So we can do, we're going to write a few methods. So we've got pop card, okay? So because everything's, self.cards is a list, we can use list methods. So we can do self.cards.pop, and that's going to, pop is going to remove the last item in the list, right? It's going to return the last item in the list and remove it from the list, okay? If we want to add a card, we can add a new card object and append it to the list self.cards. And if we wanted to shuffle up the cards, we can ask random.shuffle, and we can shuffle the list self.cards. Okay, and then this thing, because we have a way to compare one card with another, we can now implement methods like sort. Okay, because sorting is basically a comparison. Is one greater than or less than the other, and then you put them in order so that everything's, the preceding one is always less than the following one. Okay, and so .sort will work on this list because we have the double under less than. Okay, if we didn't implement double under less than, we would not be able to use sort. Okay, but this is kind of the beauty of Python, is just once you put in one of these magical double under methods, it kind of unlocks. It's like you've unlocked the ability to use a bunch of other functions that are related to this concept of, comparison or concepts of addition and things like that. Okay, so here is my class definition, where we're going to either add a card, shuffle the cards, sort the cards, or deal out a card. Okay. I also have to import the random module in order to do shuffle. Okay, so we can ask for the deck, and when we ask for the length of deck.cards, which is a list, we have 52 cards in it. If we print that out, it starts at Ace of Clubs and it keeps going. It's cut off, but it'll go until it reaches the King of Spades. I'll go ahead and I'll shuffle it, okay? And so if I shuffle this, just kind of by coincidence, we got King of Spades. I'm looking at the first 100 characters, so the King of Spades, 8 of Diamonds, Queen of Spades, 2 of Hearts, 2 of Diamonds, and then the last cards will be, the last 100 characters are 9 of Spades, 2 of Spades, 10 of Spades, and Ace of Clubs. So what I'll do is I will pop a card, okay, and it's going to deal out the last card in that list. So that's kind of like dealing off, I guess you could think of it as dealing off the bottom of the deck, or however you have this deck sorted, okay? And if we pop another card, so it's just kind of starting down here, ace of clubs, then it'll deal out the 10 of spades, and because it's just popping off the end of that list. And now if I ask what's the length of the deck is now down to 50 cards. Down to 50 cards. Okay. And so we could see what do we have? So it's okay, I ran out of space. Okay, but the end of the deck, if it didn't get cut off here, would have shows 2 of spades, but it just got cut off. And I think I can show you anything on the PDF. Okay, so you can see at the end it says 10 of clubs, 9 of spades, 2 of spades, which is what we had, you know, after I deal off these last 2, we're left with those 50 cards. Okay. All right, so let's talk inheritance. And let me give you your next view quiz answer, which is the letter B. B as in bear. B as in bear. What we will do is we're going to create another class. This class is going to be called a hand. Okay, so a hand is basically, you know, if you're playing a game, you know, poker or whatever game it is, somebody deals cards to you from the deck, and now you have maybe 5 cards, 7 cards or something. This is your hand. And so a hand is very similar to a deck in that they are made up of a collection of cards, and you have operations like adding cards, removing cards, and things like that. But there are operations that we want for hands that don't make sense for a deck. So for example, in poker, we might be able to compare 2 hands to see which hand wins or something like that, right? Or if we had bridge, if you're playing the game bridge, you might want to have some kind of function that looks at your hand and says, this is how many tricks you might take. This is what you might bid. Or hearts or something, you can say like, you know, should I shoot the moon or something, right? You look at your hand and you try to make a decision. So there's a relationship between these classes, between the deck and the hand class that, you know, makes them similar but different. So rather than having to reinvent the entire class, we can use inheritance. Okay. So to define a new class that inherits from an existing class, when you define the class, so here I'm saying class hand, and rather than just going straight to the colon, here inside parentheses I put deck. And this says the hand inherits from deck. Okay, compare that to when we define class deck, we just put in the name of the class, and then we go straight to the colon operator. So this defines a class deck, whereas over here to define a class that inherits, I'm going to say class hand, and in parentheses I put deck. And this means it will inherit from the deck. So all this does is it just creates a new class called hand that inherits from deck. And so it's going to inherit all of the methods like pop card, add card, things like that. When a new class inherits from an existing one, the existing one is called the parent. The new class is called the child. And if we have nothing else defined, then hand inherits initialize, the init dunder method from deck. But if you redefine any of those methods, the methods defined inside your class definition, the child class, will override anything from the parent class. So here I can just say the hand, as far as the hand goes, we're going to initialize it, and we don't want all 52 cards to show up in the hand. So we're going to just start off with an empty list of cards, and then we also have an empty label, okay? So we're going to give our hand some kind of label so we know what kind of hand it is, okay? So when you create a new hand, Python invokes this init method, and so if I say hand, the label we're giving it is new hand, and then we say what is cards, we get an empty list. Hand.label is the label I gave it, new hand, and that's what we'll do. And so what we can do is we can take our existing deck, or we can create a new deck from our existing class definition of deck. And then what I'll do is I will pop a card from the deck, call that my card, and I'm going to take that card and add it to my hand. So I'm going to do hand.addCard. Add card is a method I'm inheriting from the deck. And so what this will do is if I say print out my hand, again, print is a method that gets inherited from the deck. And so it says, okay, the card you popped from the deck was King of Spades, and we added that to our hand. So we can do that, okay? So what we might do is we might create a method called move cards, and what it will do is it will take cards from itself and move a number of cards into a hand. So we're going to say for I in range number, add cards, we're going to just kind of pop cards from the end of the deck. Okay? So this method takes in two arguments, the hand object and the number of cards to deal. And it's going to modify self, it's going to modify the hand, and it's going to return nothing. Okay? So we're going to just kind of move cards from one hand to another, or from a hand back to the deck. And we can use move cards for any of these things. And even though this thing is called hand is basically something, it could be any kind of object that supports this idea of adding a card. So both the hand class and the deck class has a method called addCard, so it will work with either a hand or a deck class object. Okay? And so, this inheritance feature is very useful, because that way we don't have to repeatedly rewrite the same code over and over. We can just have it inherit. Okay? And especially if you realize you need to modify something, you can modify it in one place rather than having to copy and paste that code in multiple locations. And if you need to have it different for each kind of class, you can also modify it that way as well. Okay. One problem though is that inheritance can make it a little bit more difficult to read. When a method is invoked, it's not clear where to find its definition, and the relevant code could end up being spread across several modules if you're inheriting from all kinds of different things. Okay, so here we are defining our deck class as this. We've got we have all of the methods we have: pop card, add card, shuffle, sort, and now we've added another method called move cards, which will move cards from the deck itself to a hand that we give it. And then and so here I'm creating a new deck instance, a new hand instance, and we're going to move cards from the deck. We're going to say from the deck, move cards to the hand, move 5 of them. And now if I print out my hand, because when I initialized the deck it was already in order, we're going to get the 5 cards at the end, which will be basically a royal flush and spades. Okay, well I guess not royal. Straight flush and spades. 9 through king, straight flush and spades. Okay. what I can do is I could shuffle the deck, and I could say what are the last 100 characters in the deck object, and then we could say, all right, move those 5 end cards, and we could see these 5 cards: the 9 of spades, 3 of diamonds, 4 of spades, queen of spades, and 10 of diamonds, all got moved to my hand. Okay, and then if we ask, all right, what's at the end here, we see the 10 of hearts and the jack of clubs are the last few cards in my deck now. So my deck now has 47 cards in it. Okay, if we ask what's inside my hand, inside the hand is a list, and the list inside, it's a list of cards, and that list of cards, it doesn't say stuff like 9 of spades, 3 of diamonds, 4 of spades. Those are all card objects. These are all references to objects that we have created, and so we have card objects that are stored in memory. So looking at this directly, it's difficult for us to kind of interpret just because they're written in this showing up as card objects, right? So if we have this, okay, so objects in one class might contain references to objects in another class. For example, a rectangle contains a reference to a point, and decks contain references to cards. And so we say the hand or the deck has a card. Okay, it's a has a. One class might inherit from another. So as in this is a relationship. So a hand is a deck. Okay, it inherits from deck. It is a deck. Okay, and then one class might depend on another in the sense that the objects in one class take objects in the second class as parameters, or use objects in the other class as part of its computation, and that would be a dependency. Okay. I can't read that final line here. Okay. So the last slide got cut off, but basically it just says, just a design suggestion: when you override a method, the interface of the new method should be the same as the old. Okay, so if you're going to say, let's create the method move card, but it's going to act a little bit differently for hand objects or something like that. Okay, you want to have the way that the user interacts with this method to be the same as the way it interacts with any other method. Okay, so when you call sort on a list or sort on I don't know what else you can call sort on, some other kind of object that can be sorted, the way you call it is going to be the same, right? You don't want to have to say, when it's this kind of object, these are the arguments you use, and when it's this kind of object, it changes up. You want to make the way the user interacts with these objects be kind of uniform and familiar, so that it doesn't disorient the user. Okay, because as it is, you probably, all of you have do some work in Python, some work in R, and that when you create a histogram in R versus a histogram in Python, it's different, and it can be a little bit confusing and a little bit jarring, and having to switch between the two is tough. Okay, if you had to do that within one language itself, because you're going to say, let's make when we make a histogram for this this type of data, these are the commands, and when we're going to make a histogram for this type of data, we have different commands, and when we make a histogram for this type of data, it's different commands even further. That's not a good user experience. So when you create different versions of existing methods, you want to make sure it's as similar as possible to kind of the existing experience of using that function. Okay, that's it for today. Let me give you your last view quiz answer, which is the letter C. C as in cat. C as in cat. All right, enjoy your weekend, enjoy your Monday off, and we'll see you all on Wednesday.